All right, let's continue talking about limits in here. Just as a recap, the limit of a function f of x when x approaches a equals L is telling us that as I make the x values closer and closer to x equals a, the values for the y's get closer and closer to a number L. We have talked about this before. One side limit is the limit as we approach that x equals a from the left, and the limit as x approaches that value a from the right. The left, you will see that with the negative as an exponent, and you will see the plus for the right. When we talk about one side limits, evaluating those limits when a table, a table of values is given instead of the graph, then you have to pay attention to where the right and where the left is. For this example, we have a piecewise function. It's minus 5x if x is less than 2, and minus 7x is if x is greater than or equal to 2. So we have two linear functions. And so what is given to you in here is for one part, right? So we are evaluating x equals 1.9, 1.99, 1.999, and so on. So we are approaching 2, as you can see in there, and we are approaching 2 from the left side. So this in here, it's our left. We have x values that are smaller than 2, right? And because the values are smaller than 2, we are using this minus 5x to evaluate our function. So when x equals 1.9, negative 5 times 1.9 will give me negative 9.5. Negative 5 times 1.99 is going to give me negative 9.95, and so on. All right, the other side of this table here give me x values and y values for y equals negative 7x. Negative 7x is the function that I'm using for x's greater than or equal to 2. So then I start at 2.1 and start making those values smaller, 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 and smaller. But at the end, they are approaching 2 from the other side, from the right. So again, this in here is approaching 2 from the right. All right, so in terms of notations, this in here is approaching 2 from the left. This in here is approaching 2 from the right, and that's how we use the plus and the minus. Okay, so our goal in here is now is to find who is the value for that limit as x approaches 2 from the left and as x approaches 2 from the right. So what is the limit of the function f of x as x approaches 2 from the left? So from the left, we're talking about this part of the graph of the table. So let's pay attention to what is happening in here. So when x equals 1.9, the y is negative 9.5. Then it goes to negative 9.95. Then it goes to negative 9.995. Do you see? Can you make an observation in here what's happening with the decimal? And what value are we approaching in the y-axis? So we start at negative 9.5, and every time we approach, we get closer to 2, the y value is getting closer to negative 10. You see how we keep adding 9s? 0.9, 0.99, 0.999, 0.9999. So we are approaching -10. So that is the value for the limit when x approaches 2 from the left. If we go now here and we talk about the right, and when x is approaching 2 from the right, again, we start at a -14.7 when x equals 2.1. We're going to make the x value smaller because we're approaching 2. And we just need to observe what is going on with this number. So we start at a 0.7. Then we get 0.07. Then we get 0.007. 0.0007. So the decimal piece, it's getting smaller every time, meaning that this function is approaching -14. So then the answer here for the limit is going to be -14, and that's how you will find those one-sided limits from a table, making the observation of what is happening with the y values as I make my x values closer and closer to that given value, which in this case is 2. Example number 2. Now we have that piecewise function. We have -2x minus 2. We have -2 minus 2 when x is less than -4, and we have x if x is greater than or equal to -4. So again, this is one piece of the table of values, and then this is the other piece. This piece takes care of the -2x minus 2, which is when x is less than -4. So then again, this is your left. And then when we go to the other side, okay, there we go. This one, we have the y equals x, which is the this linear function for all of the x's greater than or equal to -4. So then again, for this one, we are on the right. All right, so let's just talk about the same. Let's try to make the same observation we were talking before. This is the left. So my values are actually approaching -4, which is the x value that I want to approach in here. So as x approaches -4 from the left, right? So again, it's negative. So remember that when you have that negative value, -4, you're approaching from this side, which is the left. This is -5. So you are using -4 point something to approach -4. So then that's why you see the -4.1, and then you make your decimal smaller and smaller because we want to approach -4. All right, what is happening with the y value? So I start with a 0.2, 0.02, 0.0002, 0.0002, and 0.0002. So every time I have a 0 added to my decimal, which means that the decimal part, it's getting smaller. So then from 6.2, I am at 6.0. So these values are actually approaching 6. So then the limit is going to be 6. So the limit as x approaches -4 from the left is -6. Again, you have to watch for the pattern and observe that these numbers are approaching 6. When we go to the right, the x values are this column in here. So we are making, we start at -3.9. We are approaching from the right, so it means that we are going in this direction 9 now to approach -4. So we start here, this is minus 3. So then we go from minus 3.9 all the way to minus 3.99999. This is the y value, and this can be a little confusing because you have an x and an x. So this is the independent x value that you assign to your function. And this is the value of the function because the function happens to be x, y equals x, all right? So then the values kind of stay the same. And so if we start at negative 3.9 and every time we add a new 9, at the end, when you look at this as a pattern, we are here approaching negative 4, all right? So here we are approaching negative 4 because we're making the decimal bigger and bigger and bigger every time. So then the limit will be minus 4. All right, so the two-side limits, it's the same thing. We need to observe what's happening from when we approach a from the left, when we approach f from the right, and for the limit as x approaches a to exist, the left and the right side all need to approach L so that the limit approaches L. So let's work on a few examples. All right, so now here you see how we are adding that third part that asks us for the limit as x approaches the number. So again, one of these is the left, the other one is the right. So for x is less than minus 1, we are using the quadratic. Here is the quadratic, which means that this table, it's our left side. So let's see what is happening with the limit as x approaches 1 from the left. So again, observed this pattern. We start at 4.77 and then we move all the way to 4.999979997. This 4.9 here is telling me that these values are approaching 5 because we start at 4.7 and we are now at 4.9. So the decimal part is getting bigger and bigger and bigger. So then this approaches 5, so that is the value for the limit of the function as x approaches 1 from the left. If we talk now about the value of the function, or not the value of the value of the limit when x approaches 1 from the right, again, right is all of the x's greater than or equal to 1, which is minus 3x, that's the function that we're using. F of x equals minus 3x, and these are the numbers that we have to pay attention to. So again, we start at minus 3.3, and as we move forward, we can see how the decimal piece gets smaller and smaller and smaller. So we are now going towards negative 2, making it bigger. We're making it smaller, so we're going to the left. And so this means that this limit is actually approaching negative 3. All right. So now what happens with the limit as x approaches 1? If the limit from the left is different than the limit from the right, okay, the only way this limit as x approaches 1 exists is if a and b are the same, but a is 5 and b is minus 3, which are not the same. So then we say that the limit of the function as x approaches 1 is undefined, it doesn't exist. All right, next example. Again, we have this two-side limit. We have the tables, we have the function. So for this one, we have the function defined as a quadratic minus 4x squared plus 4x plus 4 when x is less than minus 2. That x less than minus 2 is my left side. So again, this in here is my left. So let's look at what is happening in here, because that is going to determine the number that I'm going to add in here. All right, so I start at minus 22 in here, and then I go all the way down to minus 20. So again, as we observe this pattern from minus 22.04 to minus 20.00, then these values are actually approaching minus 20. So the limit as x approaches minus 2 from the left is going to be minus 20. If we go to the other side, all right, so then for all of the x's greater than or equal to minus 2, this is the right, we use negative 4x squared plus 2x, which is this function right here, which means that we are paying attention to this pattern in here to decide what is the limit of the function as x approaches minus 2 from the right. So then, again, we start at a negative 18.24 and we move all the way to negative 19.9. All right, so you see how this decimal, it's making the value to approach the next whole number, which in this case is going to be negative 20. All right, so this limit as x approaches minus 2 from the right is going to be minus 20. So then here again for part C, A and B needs to be the same. So we are approaching the same y value as we approach our function, our x value from the right and from the left. And because that's the same, then we can say that the limit of the function as x approaches minus 2 is negative 20. All right, 2 additional examples in here. We have this function. We need to find what is the limit as x approaches 0. For the function sine of 3x over 2x, this is sort of like a trig function. And so we have it here from one side and from the other. And you have to observe and see if there is a pattern, if both sides are approaching the same number. So if we look in here, we start at negative 1.477, 1.499, and then we keep adding 9s, which means that this side is approaching 1.5. All right, so we go 1.47, 1.499, and then we have 0.49999. Every single time we add more 9s, meaning that we are making that decimal bigger. When we go to the other side, this side, right? So again, we look at what's happening with the decimals. And as you can see, the same thing is happening. We start with a 0.47 and we add more 9s and more 9 as we go. Then it means that on this side, it's also approaching 1.5, which means, there we go, which means that the limit as x approaches 0 of this function is 1.5. Last example here. What is the limit as x approaches 0 of 3 over 4 minus e to the 1 over x? Again, it's given to you. We don't need to find the values for now. We just need to find the values for the pattern, all right? So from one side, we start at 0.75 with more numbers, and then those numbers disappear, and we go all the way to zeros, which means that this got smaller, and it was reduced to 0.75, and at the end, that's the number that it is approaching. So from 0.7500085125, it just stayed in 0.75. That's the value that at the end you are approaching. From the other side, you start at a negative 0.0001362 and so on. Then it went to 0. It means that your numbers are here. So this is a very small decimal. You stay in that 0. So it means that the limit on that side is a 0. You compare them. Is 0.75 same as 0? No, it's not. Then your answer in here is going to be no, because the two-side limit doesn't exist. I hope this was helpful. Leave me a comment if you have any